We're going to work with K-factors in this lesson, so I'll show you what a K-factor is, and then we'll practice using them. When a plate is bent, some of the material stretches and some of it is compressed. The red area shows the material that has been compressed, and the blue area shows the material that has been stretched. In most cases, more material is stretched than is compressed, so the net result is the part gets longer when you bend it. Between these areas is an arc of material that is neither compressed nor stretched, so it doesn't change in length. So the flat pattern can be calculated by adding the length of the arc to the length of the parts that are not bent. So the arc is on what's called the neutral axis because it doesn't change, and the length of the arc is called the bend allowance. So if you add the length of this leg, the length of the arc, and the length of this leg, you get the length of the flat pattern. The problem is finding the location of the arc. Once you know its location, you can calculate the length of the bend allowance. So these definitions are applied to sheet metal bends. The arc or bend allowance is on the neutral axis. It's called the neutral axis because the material is neither stretched nor compressed, and is measured on the inside surface of the bend. If you take this distance and divide it by the thickness of the material, you get the K-factor. But you still need to know this distance. The only truly effective way to find this distance is to measure a strip of material, bend it, and then measure the bent part. So I've written a K-factor calculator that will help you determine the K-factor along with a few other sheet metal values. You have to measure the length of the sheet or scribe it so that you know the length of the flat pattern, and then you bend it. Once you've done that, you need to measure H1 and H2. You should also measure the bend angle and bend radius and the thickness of the material. Enter your measurements in the input section, and the output is automatically calculated. Let's quickly create a part so that you can see how this works. Start by creating a sketch on the front plane. Draw a center point rectangle on the origin. Set the height to 3 inches. And the width to 5 inches. Close the sketch, and then create the base plate. Set the thickness to 94 thousandths of an inch. Set the K-factor to 0.4, and then click OK. We're also going to set the bend radius to 2 times the wall thickness, so select the sheet metal folder, and then double-click the dimension. Name it default bend radius. And in the value cell, type the equal sign, select the thickness, and make it 2 times the thickness. Now expand the sheet metal folder, and then edit sheet metal 1. Uncheck Override Default Parameters, and then click OK. We're also going to use a sketch to bend the plate, so create a sketch on it. Draw a vertical line from the top of the plate to the bottom, and then set it 2 inches from the left side. Confirm that the sketch is fully defined, and then double-click in the graphics area to close it. Now open the Sketch Bend command. I'll explain more about how this command works later. For now, I want you to notice that the default bend radius is 188 thousandths of an inch, which is what you would expect since we set the wall thickness to 94 thousandths. Change the angle to 110 degrees, and then click OK. Now save the file in the sheet metal folder under the name K-factor. Now if you look at the diagram, we need to measure H1 and H2. We'll start with H1. Expand the Evaluate tab and open the Measure tool. H1 is measured relative to the bottom face, so select this surface and the node on the outer side of the plate. The distance is 2.054, so enter it in the H1 cell. The flat length is 5 inches because we started with a 5-inch plate, so enter it. The thickness is 94 thousandths of an inch. The bend radius is twice the thickness, so it's 188 thousandths of an inch. And the bend angle is 110 degrees. And we still need to enter H2, which is the distance from the outside face of flat A to the outside corner on flat B. Clear your selections in the Measure tool by clicking in the Graphics area. And then select the face on the right side. Now select the outer corner on the other end of the part. The normal distance from the surface to the node is 2.994 inches. So enter it in the cell for H2. The output we've talked about so far is the K-factor, which is the value we set it to in the part file. The bend allowance is the length of the arc on the neutral axis. We'll talk about bend deduction and outside setback in the next lesson. Flat A is the length of flat A, so it's the distance from the corner to the tangent point on the bend. And flat B is the length of flat B. Bent nominal length is the length of the material after it's been bent. It's measured along the center line of the material, so the material stretched almost 18 thousandths of an inch during the bending process. Now that you know what to measure, I want to show you how critical your measurements are. H1 is 2 and 54 thousandths, but what if we measured the actual part and found it to be 2 and 53 thousandths, just 1 thousandth less than this number? Change the number to 2.053. And this changes the K-factor to 0.41. Thin parts require higher accuracy measurements to get an accurate K-factor, but they're also more forgiving. Notice that with these numbers, the part stretched almost 17 thousandths of an inch, which is only 1 thousandths difference. So the K-factor for thin parts can have a wider range of values than thick parts. You might try changing the thickness to ½ an inch to see the difference. When you're finished, set H1 back to 2.054. The bend angle is also a critical measurement. Try changing it to 109 degrees. If you get a K-factor greater than 0.5, you can rest assured that your measurements are off. The K-factor is essentially the percentage of material that is compressed. In this case, 53% of the material is compressed, which causes the nominal length of the material to decrease. The K-factor was 0.4, so just 1 degree caused over a 25% change. Set the bend angle back to 110 degrees. There are a host of factors that affect K-factors and bend allowances. So when you create a new bend with a new process or a new material, you need to measure it to confirm that the K-factor you use is correct.